Hello, good afternoon. Welcome to 4th International Congress on Human-Computer Interaction, Optimization, and Robotic Applications. HORA 2022 is organized by National Technical University, Kharkiv Polytechnic Institute from Ukraine. HORA 2022 is technically sponsored by IEEE Turkey section. Thank you for your scientific contribution and support to HORA 2022. If you want, let's start the session. First paper has their first paper belongs to their Devestanga Georgieva. Are ready to present?
Yes, I'm ready.
Okay. If you want, you can start your presentation now. You have 10 minutes, please.
Okay. I'm Tsvetanka Georgieva, and I'm from University of Veliko Tardovo. My paper is about research on filtering feature selection methods for email spam detection by applying KNN classifier. Spam detection is a typical case of a problem that is most often solved by text classification. This problem can refer to different types of messages. In the present paper, the application of filtering methods to select features when detecting email spam by using text classification is examined. One of the studied classifiers in solving the pointed out problem is k-nearest neighbor. It is characterized by simplicity, a lack of training period, because the training dataset is stored and used for learning only during real-time predicting. KNN is easy to implement, but requires setting a distance measure and the value of parameter k. In addition, its performance decreases with a large number of features. The present study aims to determine whether the application of filtering methods to select features when detecting email spam can improve the results of KNN classifier. For this purpose, experiments are performed to establish the accuracy and F measure with the following feature selections methods for the dataset link spam: a relief algorithm, chi-squared, information gain, Gini index, and pointwise mutual information-based feature selection methods. The dataset link spam contains spam and non-spam messages. These tables represent a summary information about the dataset. The execution for KNN algorithm is performed using Euclidean distance and the cosine similarity as distance measures between the examples in the dataset in order to compare the obtained results. The value of parameter k used is 3 as optimal for the considered dataset. The dataset is subjected to preprocessing, which consists of tokenization, removal of stop words, and steaming. The evaluation of the text classification quality for the dataset link spam is performed by cross-validation, by dividing the dataset into 3 partitions, by stratified sampling. These figures illustrate the results from the accuracy of the KNN classifier when computing Euclidean distance and the cosine similarity measured between dataset examples. And these figures illustrate the results from F measure again about the KNN classifier when computing Euclidean distance and cosine similarity measure. The accuracy and the F measure of KNN when using all features are exceeded even when selecting 100 features using modified PMI method. This table summarizes the percentage change in F measure for modified PMI compared to other feature selection methods for the KNN classifier and dataset length span. Values that represent statistically significant improvement or both. This column on the table is about Euclidean distance, and this is about cosine similarity measure. The conclusions from this research can be summarized as following. Experiments are conducted to calculate the accuracy and F measure of the email text classification with different feature selection methods and different number of selected features. The results of two distance measures between the examples in the dataset are explored. The results obtained allow us to conclude that the modified PMI-based feature selection achieved acceptable accuracy for detecting email spam, even with a small number of selected features. Thank you for your attention.
Thank you for your presentation. Dear participants, do you have any question about this article? Okay, no question. Thank you again. I wish you success in your career. The next paper belongs to dear Tvestelina Miladenova. Are you ready to present?
Yes, hello.
Hello. Okay, if you are ready, you can present.
Okay, let me just share my screen. Yes, do you see my screen?
Yes.
Okay. Hello, my name is Svetlana Modenova, and I'm going to present our research on the design of a sensor measuring station for patient parameters remote monitoring. A continuous increase in the number and development of smart devices is observed in every area of humans' daily lives. The ability of low value helps for the popularity and wide range of application of such devices. The application of smart devices in agriculture comes late because of the need for an independent power source of the devices and the need for data transfer through vast distances. At this moment, even these important requirements have a solution with the help of rechargeable batteries, photovoltaic panels, or networks from the type of LoRaWAN. There are multiple different already built such stations, but their functionalities are limited and does not cover all of the specific requirements of the farmers and the stock breeders. In particular, pastures and meadows are high nature value ecosystems, providing natural food and at the same time caring for carbon storage, biodiversity, water purification, erosion control, and landscape conservation. Maintaining them in good agricultural and ecological condition is extremely important. And conventional methods for assessing and the productivity and quality of pastures are subjective, time-consuming, and applied for assessment and monitoring of pastures for only small areas. In recent years, methods for estimating pasture productivity have been developed based on data from satellite remote sensor, as well as data from multispectral scanners in the area in order to analyze and have some predictions. The analysis of the condition of pastures and meadows requires the presence of sensors distributed in space for various parameters integrated in a wireless sensor network. Soil and climate factors such as soil saturation, temperature condition of the soil, light, rainfall, phase of the plant development can be gathered and analyzed as well. The determination of the amounts of nutrients in the soil and their influence on the growth of the species is realized with the help of sensors and field studies. During the recent years, different types of sensors have been used in agricultural practice to obtain fast and timely information on key soil indicators. Sensors mounted in depth also provide additional information on the values of the main nutrients, such as nitrogen, phosphorus, and potassium. The classic measurements of nutrients are made by specialists who take soil samples over a long period of times and provide them for measurement in laboratories. With the use of sensors, the dynamics of the parameters can be automatically monitored over a longer period of time. For sensor networks built in vast open spaces and scattered over long distances such as several kilometers, it's necessary to assess the propagation of radio waves and the correct positioning of the base stations that will collect the information from the measurement stations. The base station transmits the information to the data storage and the processing center. WAR1 is a technology that is suitable for the realization of such type of networks. It offers a network with low power, reduced power consumptions, but with limited data volume. It offers wireless connectivity of local battery-powered devices to regional national networks in the global internet. The aim of the development of our system, of the proposed system, is to measure different soil parameters, such as soil temperature, soil moisture, electrical conductivity, again, of the soil, pH, and the content of the three main elements, nitrogen, phosphorus, and potassium, as well as some environmental measurements such as air temperature, air humidity, and atmospheric pressure. To achieve this target, it's necessary to have some sort of electricity supply, and our proposition is a photovoltaic panel, where the energy is stored in a battery that supplies constant power to the system during the day, the night, and the days with limited sunlight. To measure the parameters of the soil and the air, we chose a combination of sensors that export the registered values in numerical type. The collected data from the station is transferred using ORA network to ORA1 gateway, and from there to the data server for further analysis. The gathered values, the measurements, are received by sending a request from the server and to the server, excuse me, and the user can receive the values of the base parameters shown in these two tables, as well as some additional parameters based on further calculations. Once the values are registered, the subjector factor is avoided, and the measured values are sent straight to the data server in a digital format. The measurements are completed every 15 minutes of the day. The converted data in the microcontroller shown in this photo from the soil and the air sensors are with volume of tens of bytes. We anticipate adding a module with a micro SD card to archive some of the data, but the current version of this system transfers the data via Wi-Fi interface to the data server. The micro SD card is not done yet. We are working on the LoRa interface as well, so the data can be transferred over longer distances in the absence of appropriate infrastructure, in the absence of Wi-Fi. The collected data of the measuring station and the additional extras are anticipated to be available in the form of information system, which can be used by farmers, by vets, by users in every form. In conclusion, in the process of creating the measuring station for the soil status of pastures and meadows, it was established that there is a need to collect data about additional parameters of the environment that affect the development of the grass. The measuring system, and in particular the microcontroller, can be programmed to measure the solar radiation as well. And it's necessary to select, install, and train and program appropriate sensors for the microcontroller. Once when the measurements are started, there is also a need to record the GPS coordinates of the station because there might be several stations. With the help of the proposed system and artificial intelligence, it's possible to refine the necessary actions to take care of the pasture of the meadow, to predict the amount and quality of the produce by analyzing the different parameters of the field, monitoring the atmospheric conditions, and etc. Essential factor for the analysis is the extraction of knowledge for a unit of pasture and using intelligent devices for multiplexing during the process. Thank you for your attention, and if you have any questions, I'll be happy to answer them.
Thank you for your presentation. Dear participant, do you have any question about this article? Okay, no question. Thank you again. I wish you success in your career.
Thank you.
Next paper belongs to dear Theodore Kalushko.
Yes, I
Are
am.
you ready to present?
Yes, I am.
Okay, you can start your presentation if you want. You have two papers.
Yes.
Okay.
Can you see the screen now?
Yes.
Okay.
You have 10 minutes. Okay.
Yes. Okay. Thank you. So, dear colleagues, my name is Theodor Kalushkov from St. Cyril and St. Methodius University of Veliko Tarnovo, Bulgaria. And now I will present you our report about selection of ad blockers according to their type of installation. Online advertising is one of the main sources of profit for the web content creators and plays a critical role in maintaining free online sites and services. Advertisers directly pay to web content creators a percentage of the money generated from online ads. Online ads can be presented in a variety of forms, including text, banner, flash pop-up, wallpaper video, and many more. Web content creators emphasize the intrusive model that includes the invasive ads described above. They are placed on almost every website and often distract users. As a result, users become annoyed by pop-up ads, banners, and videos which start playing automatically when the website loads. In order to block advertisements on any websites, many users use ad blocking software, which is also called ad blockers. The communication between online page visitors, third-party servers, the advertisers, and web analytics providers is realized in the following manner. First, entering a specifically selected website, several data transfers are taking place without our knowledge. If you are browsing a web page through visitors access, you first connect to the host server. It contains the content that web publishers publish on the web and links to the third-party servers. Second, when website loads, user clicks on a dedicated area. Links are downloaded and analyzed by the browser. On third place, the communication between the visitor and the third-party servers begins. Some of the most popular ad blockers are described on this slide. Content filtering ad blockers. Examples are AdBlock, AdBlock Plus, uBlock, and uBlock Origin. They use personalized databases or filter lists to distinguish between dangerous and secure content. On the second place, tracking blockers. This group includes ad blockers like Ghostery, Disconnect, and Privacy Badger. They also make blocking lists, but implement also some algorithms and machine learning for detection of tracking behavior. On third place,
sorry, your first page appear on the screen.
Sorry, my first page?
Yes. Your first page of the slide.
You don't see my other pages?
I see, but the first page is appeared.
Okay, I will start sharing again.
Okay.
Can you see now?
It changed, yes. Okay, continue, please.
You can see now the list or the first page?
Yes. No, it's maybe 50 page.
Okay, thank you. So on the first place, browsers with integrated ad block functionality. Typical examples include Brave browser and Tor browser. Except these, so popular web browsers now include a private browsing feature. In Mozilla Firefox, this feature is known as private browsing, while Google Chrome is called incognito mode, and in the Internet Explorer and Edge, it is known as in private. According to their developers, when these browsers are launched in private mode, they maintain full privacy of users, not keeping track of web browsing sessions, visited website, search history, downloaded history, web form history, cookies, and temporary internet files. On the fourth place, ad blockers for mobile devices. Mobile ad blockers are also a blacklist of network domains, which prevents or removes unwanted items from loaded web content. On the fifth place, ad blockers with filtering on a network level. They use DNS, VPN, or proxy servers. For example, DNS blocking relies on host files containing domain or subdomain addresses to block or similar DNS information. This approach can block domain or subdomain detail requests, but it cannot block specific URLs. Such projects are Pi-hole and Edgar. Can you see now the next slide?
Your fifth page is appeared.
So there is some kind of technical problems.
Yes, now sixth page is appeared.
Okay, can I present like this one in this mode?
Okay.
Okay. AdGuard is a small process that runs on Raspberry Pi and blocks ads at the DNS level. AdGuard works by using blacklists that includes ad server domains and redirects them to an empty IP address. So the requests does not reach the ad servers and the ads are not retrieved. It is placed between the device and the DNS server upstream and blocks any requests to non-advertising and tracking servers. Serious advantage of DNS blockers is that websites can detect them and their users don't receive browser messages like our website is financed by advertisements, so if you want to see the content, please disable your ad blocker. Unfortunately, there is also a disadvantage. It is relied to the requirement that the users must have some network knowledge to set up their devices to work with the blocker. The most popular classification divides blockers onto three main types: ad blockers, tracker blockers, and content blockers. Other approach of another large group of scientists focused on the end results of activity that ad blockers perform, compared on the basis of actual experiments. They take into account the achieved optimization efficiency when using each of the ad blockers. Measurements are most often reported in the number of blocked ads and total loading time before and after the block. When using ad blockers by blocking certain queries, the amount of downloaded data is significantly reduced and the loading time of different pages is improved by milliseconds, sometimes even by seconds, especially when removing intrusive advertising. The results from the experiment we made are represented on this slide. It shows the number of requests and size and time to download an identical web page with and without use of ad blocker. We suggest another approach for separating ad blockers. It refers to the type of installation. Ad blockers can be sorted in the following manner. First, host integrated blocking. Second, browser integrated protection. On third place, ad1 blockers for browsers. On fourth place, independent browsers for private surfing. Fifth, independent installation. 6 DNS, VPN, and proxy-based ad blockers, and this can be divided on 3 subcategories: via cloud structures, via local virtual machines, and via dedicated microcomputer. OS integrated blocking as well as browser integrated blocking are appropriate for low computational power platforms like mobile devices. They should only cover minimal system requirements for the specified OS installation. Unfortunately, blocking abilities in this case are lowest compared to the following types. Adblockers for browsers allowed to be installed on any computer, not being picky about its hardware resources. Therefore, they are one of the most common used. Although they are processing resources, one of the benefits they bring to the user is observed as speeding up the operation of the device when browsing. Independent browsers for private surfing and independent installations are also weakly dependent on hardware and make up small part of all adblockers because these browsers don't support some functionalities available in traditional ones. Moreover, Tor browser in particular is also characterized by certain slowness in the work due to forwarding of packets and encryption of connections between individual servers that it uses. Independent installations are also unpopular because their work is highly dependent on the type of browsers used and their principles of operation. DNS and VPN proxy-based adblockers via cloud structures fully cover the advantages of clouds. The user does not need any additional computational power, but pays on demand for the user cloud services. DNS and proxy-based adblockers via local virtual machines require powerful computer configurations in order to support the additional platform virtualization. As well as cloud-based blockers, these can apply most complicated adblocking algorithms with large block list databases. DNS and VPN proxy-based adblockers via dedicated microcomputer. The end user computer can contain very limited processing resources because adblocking is outsourced into the dedicated external structures. These external microcomputers can be low power, low processing boards like Raspberry Pi, for example, Raspberry Pi. And as a conclusion, most of the adblockers does not require serious processing power, and more often the benefits of their use far outweigh the investment in resources. Adblockers speed up website surfing, increase the network security, and provide more comfortable working environment for the user. With this, I want to thank you for the attention, and I'm ready to answer your questions if you have.
Thank you very much for your presentation. Dear participants, do you have any question about this study? Okay, no question. Thank you again. I wish you success in your career, dear Theodore.
Now the next presentation.
Okay. I am sorry. I forgot it. You can start your second presentation.
Can you see now the screen?
Yes.
Okay. The second report that I will introduce you is called an approach for increasing the personalization in blended learning environment. The main goal of the report is to explore the possibilities for personalization of learning and at the same time for collaborative work in the conditions of blended learning. The results of the research will contribute to the development and implementation of local virtualization system, which will increase the efficiency of the learning process and provide additional opportunities for sharing large multimedia content, increasing the personalization of learning and teamwork in the conditions of blended learning. First, I want to comment some of the basic terms used in the research work. We understand the term blended learning as a method of teaching and learning that integrates technology with traditional classroom activities. The personalization of learning could be seen as a set of methods, techniques, and approaches for providing learners with self-learning tools that allow them to progress according to their abilities to choose the type and the way of delivery of the different learning resources, and all this based on their individual preferences, needs, interests, and learning style. The term collaborative work we understand as a way of learning where students work together in groups in order to achieve common goal. Every individual is responsible for the learning progress of other in the group and, of course, for its own. In that way, the success of each student determines the success of the group as a whole. Serious problem in e-learning, in particular blended learning, is the low level of personalization. Large number of e-learning resources can be found easily, but it is very difficult for the students without support from a teacher to find the most appropriate e-learning resource for their individual learning profile. Every student has individual learning style. Most of the students have no idea what is their learning styles. Determining the different user learning styles, especially when when it is blended learning, can be done also by using specialized tests. Most of the learning styles theories offer specific questionnaire by which very easy may be found the appropriate learning style for an individual only by answering a number of questions or solving specific cases for real learning situations. There are a lot of theories for defining learning styles. In the present report are discussed just two of them, the theory of so-called perceptual modalities and the theory that determines the learning styles according to the student ability to cooperate during the learning process. Perceptual modal theory. According to this theory, there are three basic modalities to process information to memory. Visual, learning by seeing; auditory, learning by hearing; and kinesthetic, learning by doing. The following figure presents the most appropriate tools for design and implementation of e-resources consistent with a different way of processing information. Learning styles theory according to the student ability to cooperate. This theory defines three different learning styles: cooperative, competitive, and individual. The competitive students prefer to study in a group. They are communicative, like to discuss, to analyze the problem with others. In that way, they achieve easier and quicker success in the learning process. The competitive students prefer to study in competition with the other in the course. Their results in the learning process depend on their success in the competition. The individual students work and study alone. They are not so successful in the project teamwork when they are obligated to cooperate. Some circumstances that led to the necessity for developing the system for virtualization in our faculty of mathematics and informatics are listed here. Some disciplines studied in our faculty presuppose high competence and development and use of virtual structures. Also, due to specific of study disciplines, there are often a need to share large files with multimedia content. At the moment in our university, to exchange and deliver teaching materials, the platform of the university, email, social networks, and portable memories are used. But in most cases, these opportunities often have limits and on the volume of the shared files. To increase the efficiency of the learning process, it is necessary to build a local system with large disk space, allowing the creation of virtual machines and ability to flexibly manage learning content and personalization of the learning process. Some disadvantages of our platform. Since the beginning of COVID-19 pandemic situation, the university changed the internal regulation and all began to use with priority e-learning system. Unfortunately, it has some disadvantages from which only students and teachers suffer due to the specific of study materials. Most of these disadvantages are listed on this slide. And the description of suggested approach. The suggested in this paper approach for blended learning through a virtualization system is depicted in details on this figure. In the beginning, the teacher develops a learning content in different ways according to the different learning modalities. On the second place, only the learning materials for the individual learning style are implemented in the individual virtual machines. Then before starting the learning process, every student fills a questionnaire that aims to determine the modality. It means learning style of the student. When the individual student's modality is determined, the system provides him credentials, username and password, that give him an access to the virtual machine with materials exactly and specially for this own learning style. After that, the real learning process starts. As an additional functionality, the virtualization system should allow easy file transfer services without limitations for file formats exchange. This will ensure opportunity for conducting competitions and collaborative work when it is needed. With this functionality, our system will meet the specific requirements of the second theory of learning styles discussed in this report. For access to the file share resources, the student can use their credentials that have already received after passing the test. And future work. In the future, we plan to upgrade the system with new functionalities, opportunity for online access to the learning content in virtual machines, and for gathering information about students' behavior when interacting with the system. Thank you again. And if you have any questions, I'm ready to answer.
Thank you for your second presentation. Dear participant, do you have any question about this paper? Okay, no question. Thank you again. I wish you success in your study.
Thank you.
Next paper belongs to dear Mustafa Al-Kafaji. Are you ready to present? Dear Mustafa Al-Kafaji. Okay. The next paper belongs to dear Shi Ukli. Okay. Seems not online. Dear Ravindu Vithana, are you ready to present?
Yeah, I'm ready.
Okay. You can start if you want.
Okay.
You have 10 minutes, please.
Okay. Can you see my screen?
Yes.
Okay, great. Servport. Servport is a process re-engineering and optimization of processing vehicle service centers in Sri Lanka. This is the author's details of my project, and I am RDK Vittana, Faculty of Computing, Sri Lanka Institute of Technology, Malambe. These are the overview of my presentation, and okay, let's begin. In the modern technological world, information and communication technology plays a considerable role in communities' daily activities. In last couple of years, technology has significantly changed society in many ways worldwide. The technology has helped to expand the living level of people as well as the growth of the companies. As the result of that, in course of the economy's growth in countries, the development of ICT transform economics and societies in various ways by lowering information and transaction cost, establishing new collaborative model to boost the workers' efficiency when considering the service industry, maintaining quality and customer satisfaction need a beneficial for the company's growth. The use of technology is an essential certain for that. Usage of the vehicles are increasing around the world. Thus, the vehicle maintenance has become the key factor when considering the continuous performance of the vehicle. This led to the increased need to the vehicle service providers. However, there are some challenges faced by the vehicle service providers when providing a high quality service within a reasonable price range for the customers. To provide the solution for the customers as well as the vehicle service centers regarding the problem both individual face during the vehicle service process and improve the efficiency for the process. A process of optimization solution for the vehicle service centers is planned to introduce. According to the findings, a process optimization tool was not yet introduced for the vehicle service sector in Sri Lanka. These are the findings that Sri Lanka Motor Traffic Department is the total how the increase of the total number of vehicles in Sri Lanka. This is our research gap to find even though the vehicle population is increasing continuously and the demand for the vehicle service centers are increasing continuously. Because of that, we introduced the process optimization solution because the Sri Lanka does not introduce yet this type of solution to the vehicle service in Sri Lanka. This is our research problem, how to process re-engineering and optimization to improve the efficiency of the vehicle service process and improve the customer satisfaction in the vehicle service station. Okay, let's begin our literature survey. In service business, customer happiness is a critical factor. It is in determining the company's success. In order to remain competitive in this market, business must work hard to both acquire new customers and keep their current customers happily. According to the several researchers, and increase the firm performance is directly linked to the improve the customer satisfaction. According to the several researchers, it will eventually bring much money. As a result, improve customer retention and decrease customer churn requires a keen eye on customer behavior. In order to keep customer, it is critical that they are happy with their purchase. According to the studies, independent variables such as customer service and price justice plays a significant role in making customer happy. It is important to note that each independent variable influence in the dependent variable in this case. Your business will benefit significantly from delighted customers who will promote positive words of mouth about your brand and help build your brand reputation. Considering all of these points, effect have been made to develop effective prediction model to predict where the customers will retain and churn and it impact to the company's profitability, considering factors affecting customer satisfaction. As a solution, machine learning model was chosen to predict the next service date in service servport vehicle service management system, because some customers forgot their next service days. Because of that, we predict those details and remind the customers to how what is the next service date of their work. And prediction future is becoming increasingly important to the modern corporate sector because of the rapid changes that affect even the most established structure and the need of peace and realistic measures value in the future. Considering such the time series realize the demand of vehicle service demand time series and anticipate accurately stable and predict a pattern transaction curves resulted in high predicting accuracies. This is our methodology. This is our overall system diagram and what the tools that we use to develop this system. We consider employee data, stock and price data, customer data, and vehicle maintenance data. We use employee data to predict employee efficiency, and we will show the result in our web app. And we use stock and prediction data to predict stock demand and price prediction. And we use those details to analyze the cost allocation. And customer data we use to predict the customer retention, predict impact on profitability, and we show those details in our web app. And vehicle maintenance data we use to develop next service date, and we send auto-generated email to the customer's mobile to remind the next service date. And customer retention and impact on profitability. We consider service price, distance, service quality, response time, and customer service to predict those details. Using these factors affecting for customer satisfaction, the current studies investigate 4 machine learning models to find the most accurate machine learning model to predict the customer retention and impact of vehicle service centers profitability. When we considering employee efficiency prediction, we first identify the employee skill set, predict employee efficiency according to their skills, and we assign, after we predict those details, we assign the employee for the relevant task. When we consider product demand and price forecasting, first we predict the future demand of product, and we predict the price of when we forecast in the product of price. Both of that we doing using ARIMA model. The reason for we doing this one to continue initial service in vehicle service centers. Next service date prediction, we use past history data, the vehicle service data, and we predict next service date using logical regression, and predict a price for the product is using ARIMA model. And after that, we email relevant customer, notify their next service date. Our evaluation and results are first, according to the obtained prediction results, decision tree algorithm obtains 66.66% accurate rate. Logical regression algorithm obtain 50%. Random forest algorithm obtain 83%, and linear regression algorithm obtain highest accuracy rate 99%, 2.9 accuracy rate. Therefore, the linear regression algorithm were used to predict employee customer retention. These are the how customer retention is work. First, we put our this data to the linear regression algorithm. After that, we can predict the customer is retaining customer or churn customer, and how the percentage-wise impact the vehicle service that the relevant customer. And when we consider the employee efficiency prediction, we use a decision tree algorithm to predict employee efficiency, and the accuracy rate is 90%. The ARIMA model we use to product demand and price forecasting, the p-value of that is 0.2699. And the next service date prediction, we use a logical regression algorithm to predict those details, and the accuracy rate is 89%. The conclusion, in the research presented an intelligent vehicle service management system utilized several machine learning approach. As I mentioned above, since there were no effective technique to boost job efficiency, increase vehicle benefit and fulfill the customer satisfaction in the present service centers, and the proposed solution solve each of them by utilizing advanced machine learning model methods with high accuracy. This is our final product, and this is the web application we used as an internal software, and this is the mobile application we use to give the customers. And these are the reference we follow to before we start this presentation research project. And this is the end of my presentation. Thank you for listening, and any questions?
Thank you for your presentation. Dear participant, do you have any question? Okay, no question. Thank you again. I wish you success.
Thank you.
Evet. Last paper belonged to dear Rosissa Radoeva. Are you ready to present?
Yes, I am. Hi.
Hi.
Okay.
If you want, you can start your presentation.
Yes. Okay, I hope you see my screen.
Yes.
Okay.
You have 10 minutes, please.
Okay. Okay. Today I will present you the paper overview on hardware characteristical virtual reality system. The scope of the paper is to present an overview of the different types of virtual reality system from the hardware point of view. In order to outline the importance of implementation of VR to enhance the conventional education to use of VR technologies in education will be presented too. VR is represented as a three-dimensional environment made up by a combination of software and compatible hardware for displaying the environment. In the age of advanced technologies that we live, software tools are used as a media to improve the quality of education. So the modern information technologies allow the presentation of a variety of visual information in three-dimensional space. The development of computer technology has been changed the learning techniques, and in recent years, 3D modeling and animation have been actively introduced in education, providing educators with new tools that helps learners more easily to master studied material and increase their motivation. Here, I will present you a brief history of VR systems, and the history started in the late 50s of the previous century when Morton Hellick demonstrated a prototype device called Sensorama. The device was a simulator for 1 to 4 people, in which 3D images were projected with stereo sound, chair movements, and realistic smells. Actually, this was the initial approach towards developing a VR system. Later on in 1965, the first head-mounted display was introduced by Ivan Sutherland, and it was named the Sword of Damocles. This was basically the first hardware concept and prototype for a VR system. And in 2012, it was introduced the Oculus Rift, the first affordable high-quality head-mounted display, which started as a Kickstarter project. And after that, a large number of products are overflowing the market, trying to implement the idea of Ivan Sutherland, which is basically the pioneer of this area of technologies. On this slide, I will briefly introduce different types of VR system so that next an analysis of the hardware characteristic can be made. According to the degree to which the user is isolated from the physical surrounding, there are three types of VR: the non-immersive system, semi-immersive, and fully immersive. Non-immersive systems, this is the basic type of VR system, and the VR world is displayed without additional devices such as head-mounted displays. Also, this type of VR is called desktop VR. Semi-immersive systems still use a conventional monitor, but they support partial body tracking through the use of special gloves or special glasses. Actually, the augmented reality is an example of such system. And the fully immersive system are the ultimate version of VR systems, allows users to attempt virtual environments as the real world. From a technological viewpoint, a VR system consists of three key components: input devices, output devices, and software. In general, input devices are responsible for interaction, output devices for the feeling of immersion, and software for a proper control and synchronization of the whole environment. Based on these key components, we summarized common hardware characteristic for the different VR system, and the result is presented on the table on this slide, where you can see the different parts of that consist one VR system, and these three types of VR system, and what do you need to make one system for you. Hardware characteristics are basically separated on output devices and input devices. Output devices transmit continuously computer-generated information to the user via multiple sensory modalities, such as visual, auditory, and tactile feedback. And VR basically rely mostly on the visual modality. Here we have two types of displays: stationary displays and head-mounted displays, where the stationary displays are used in desktop VR and in some semi-immersive VR systems. Head-mounted displays are used for immersive simulation. As the name shows, they are worn on the head and usually provide a stereoscopic view of the world. They can be divided into wired or mobile. The name wired, it means that a separate computer is required to be able to use these devices because they don't have any computing hardware except sensors. And the mobile head-mounted displays are divided in three groups: simple casing and standalone systems, where simple casing They rely on the smartphones and the standalone systems do not need any additional PC or smartphone. They have integrated graphic processing unit, generating, rendering, and visualizing 3D environment on the displays. In the table presented on the slide is a comparison between the most common models, head-mounted displays of the main competitors, Oculus and HTC. We have 4 different models. The first 2 columns are representatives of wired head-mounted displays, and the next 2 columns are from standalone mobile category. One of the main differences between them is that the first group don't have limitations related to memory and battery life, and thus make them a good choice for visualizing complex data requiring more computational power. In case that the user do not have concerns about battery and memory limitation, mobile head-mounted displays are better choice due to computer independence. Both mobile models presented in this table have improved resolutions, which provide a clearer visualization. The other part of VR system input devices, there are 3 different subcategories for input devices, which are mainly associated with head-mounted displays. The first group is the controllers. They provide the user with the opportunity to communicate directly with the virtual environment. The controllers are head-worn and provide input in the form of buttons and continuous input by top-mounted joysticks or touchpads with additional 6 degrees of freedom tracking information. The second group is composed by navigation devices. They provide the user with a more intuitive moving experience. These devices are used to give the user the illusion for traveling through the virtual world. And the third subcategory of input devices consists of tracking technologies, which can be divided in full body tracking and hand tracking. On these images, the first one is the controller, or representative of the controllers. The second one is a representative of navigation device, and the third one is basically a tracker for user movements. And well, we will finish with the usage in education. The transition from analog to digital teaching practices is also changing the way how teaching looks like. The role of educator changes from delivering content to facilitating content. They will be focused on creating research conditions instead of providing ready-made knowledge. The advantages of such an approach are obvious. Not only does it reduce distraction, but it can completely immerse the learner in the simulation. Some simulations are so well realized that the student begins to react as in real life. Learners will not only gain important information, but will also be able to start practicing their skills from day one. Some of the benefits of VR training that will help for better training are presented on the slide. Visual learning, the trainings can be performed remotely, memorization and reproduction of what has been learned, and a lot more. Analysis, where VR technologies are one of the fastest evolving areas of the modern world. And one of the most...
Sorry, on the screen, your first page is appeared. Okay, okay.
Okay.
It's changed.
Now it's changed, right?
Okay. Now continue. Okay.
Okay, sorry. Okay, so one of the most important features of these technologies is that they can make the invisible visible and inaccessible accessible. And basically, this was my last slide. So thank you for your attention. And if you have any questions.
Thank you for your presentation. Dear participant, do you have any question about this paper? Okay, no question. Dear Shi Ukli are ready. Shi Ukli. Dear Mustafa Al-Kafali. Okay. Dear Ravindo, pardon, dear Rosissa Rodeva, thank you for your presentation. I wish you success. I forgot it. Dear participants, thank you for your attending. The session is over. I would like to end the session. I suggest you to attend the next session. We'll start shortly. See you in next sessions. Goodbye.
Goodbye and thank you.
Goodbye.
Goodbye.